We'll now talk about multi-dimensional arrays. We've already learned about 1D arrays, right? We can have 2D arrays, 3D arrays, 4D arrays. So as many dimensions as our memory can handle. Typically, we just use 1 and 2D arrays in this course. So to declare a 2-dimensional array, right, with a 1-dimensional array, we gave it a size. We gave it 1 size. Well, now we need to give it 2 sizes, 1 for each dimension. Right? So we'll have a data type here and a name. Then the first size we give it will be the number of rows, so the array of m rows, and then n columns, so rows and columns. C stores things in what's called row major order. Right? We use a nested for loop, meaning one loop inside of another to access the array information. Typically, we'll access everything in one row, column by column, switch to the next row, and then access it column by column. We could just as easily access things column by column and then switch rows. Right. But now you can see when we refer to our array, we'll refer to it by 2 index subscripts, right? The row and the column. So here this is row 0, column 0. Here this is row 0, column 1. Row 0, column 2. Row 1, column 0. Row 1, column 1. Row 1, column 2. Row 2, column 0. So you can see, notice this index is the same because this is the column and this is column 0. This index is the same in this column. Column 1, second index 1. Right, notice the row index is 0 all the way across here, same row. Right, so we need, for a 2D array, we need 2 subscripts to access it. Okay. So we can initialize 2D arrays. In this case, now I'm declaring an array named A. It's going to have 3 rows and 2 columns. It's of data type int. My initializer list, then, I have to indicate what goes inside what row. So we still use the outer curly braces, and inside here, in curly braces, this says what goes in row 1. Sorry, row 0, index 0. So we'll have a 0 be stored in row 0, column 0. A 1 gets stored in row 0, column 1. Then this says what goes in the next row. So the next row is row 1. This first element then gets stored in column 0. This next number 3 gets stored in column 1. Right. This list right here in curly brackets is what goes in row 2. The 4 goes in the first column. The 5 goes in the second column. Right. Now you can do that if you leave out the inner braces and just type this one long list. You get the same effect. It will just start here and say this goes in the first row, first column, first row, second column. As soon as it runs out of columns, it'll put it second row, first column, second row, second column. Right. Third row, third column, or third row, first column, third row, second column. So you can write it this way as well too. A lot of times with 2D arrays, you know, we're usually not initializing things. We can initialize them to all zeros. That's typically more what we do with an initializer list. So row major order, like I said, the first subscript you put when you declare the size, that will be the number of rows it gives you. The second subscript will be the number of columns. Right, so that's just referred to as row major order. And that's the way they're stored in memory. Row 0 is stored first with each one of the column information, then row 1 is stored next with its first column through the nth column, and so on until the last row m is stored with the 0 through n columns, right? Or the 0 through n minus 1 columns if we're numbering indices. Right. So let's take a look at how we can access some of the array elements. Let's just go ahead and run this example in code blocks. We're going to end up storing the numbers 0 through 14 in a 2D array. So here I'm using rows and columns. So I'm using 2 variables to indicate then that this will be the value 5. So we've assigned the size of 5 to this, and this will be 3 by what I've assigned to columns. But I'm using the variables here as a good reminder for which are the rows and which are the columns. Right. Now I'm going to declare 2 other variables, I and j, that I'll use as index subscript locations to walk through the array. My first outer loop then, I'm going to set I equal to 0. I will equate to the rows. As long as I is less than my total number of rows, I'm going to add 1 to I. Then within there, I've got another for loop. Right? We'll set j equal to 0 as long as j is less than the number of columns. We will store this value then in the location array index I and index j. Right? And it's going to be I times the number of columns plus j. All right, let's just do a run to cursor, build this up, and see how this works. All right, so we can see here, right, our variables, rows, and columns are initialized. Array, now what I'm getting here, this hexadecimal number, it is a memory location. My array is so big now, it's not showing the whole array in memory. I'm just showing me the address of the array. Right, I and j haven't been initialized, so let's just step in. So we can see, next line, I set equal to 0. 0 is less than the number of rows. We're waiting to execute this line where we'll go ahead and set j equal to 0. 0 was less than the number of columns. This was true. So now we are in here. So we'll take I, which is 0, times columns. That'll give us 0 plus 0. That'll store then the value 0 at index location 0, 0. Right, now, if I want to see what's in array at index 0, I can just type in here array, at 0, 0. So I can, oh, I didn't like that. Don't perform pointer math or incomplete types. Oh. Right. All right. Really, still, it won't let me show what's in my array. All right. I'm trying to get to let me to watch it as an array. Come on. There we go. Right-clicked on the wrong thing. I want to go to properties. I want to say, watch is in an array. Give me the base 10. Still, it didn't do it. Okay, guess I won't play with the debugger anymore. Edit watch. I'm trying to change the name of that. So we can at least see the row. No, it won't even. Still, it won't let me access it. Well, that's not fun. I used to be able to access it in previous versions of code blocks. Sorry for the waste of time there. All right, let me just stop this. Let's restart, run to cursor. All right, as we step through this now, we see I and j becoming 0. We're going to store 0 at the end at 0, 0. We're going to store 1 at 0, 1. So as we go all the way through this, if I just go ahead and do a run to cursor, let's print this information out so we can see it. All right. So here's what prints out. This is a rows. So here I am in row 0, column 0, row 0, column 1, row 0, column 2, row 1, column 0, row 1, column 1, row 1, column 2. All right. Let's stop the debugger. Let's do a run to cursor. All right, let's watch this pop up. So if I say next line, right, I is equal to 0, let's do next line, j is equal to 0, and now I say go ahead and print that out. All right, when I pop this up, we can see I0, J0, we get our first 0. Right. It's going through this loop now. It's going to increment j by 1. It's going to say is 1 less than the number of columns? It will be. Right. So we'll see now if we pop this up again. Right, we have the number 1 printing out. I'm using a field width of 5 so that it's spacing this out for me. Right. If we do another next line, right, so we go ahead and we do I is 0, j is 2, we got that third line, that third element out here, and now when this j becomes 3 was not less than columns, this failed, comes down here and executes this new line. All right, so if I say next line, all right, it's going to start then, we see our cursors down here on the next line. That's the end of this part of the loop that's controlled by I. It comes back up. Now if I say next line, we can see that I increments by 1. 1 was less than number of rows, so we're going to restart the j loop. Right, next line, we said j equal to 0. We pop up and we start writing things in the next row. And we can watch as we iterate through here. It's going to print this out row by row, column by column. Right, when j is done, right, now we have the next row completed. It's going to give us the new line character. It'll execute this printf so that like when it starts printing the next one, it's down here. Right, and we'll watch it go through, watch these values change for the indices. Right, running this yourself, you're seeing these other numbers popping up. Right. So you'll want to save this example or you want to refer back to it because this is a really good way to show you how to iterate through a 2D array, how to use the nested loops, control the access to the array elements by the number of rows and columns. Right. It reminds you of the index notation where you have to have 2 subscripts for a 3-dimensional array. If we had a 3D array, we'd have to use 3 subscripts. 4D array, 4 subscripts. All right. We don't commonly do that. All right. That's the end of multi-dimensional arrays. We'll have some other lectures or some other examples where we actually then use them in programs.